Welcome back. In this video, we will talk about the solubility trends of salts. As we know, the solubility of a salt is governed by two important factors, that is, the lattice energy and the hydration energy. Lattice energy is actually the energy required to break attraction between ions of a crystalline substance. This indicates that more the attraction between the ions of a crystal, more will be the lattice energy, and hence lesser will be the dissolution. So clearly we can say more the value of lattice energy, lesser will be the solubility of salts. For example, the lattice energy of sodium chloride is around 787 kilojoules per mole, and that of potassium chloride is around 717 kilojoules per mole. Now on comparing the two, potassium chloride is having lower value of lattice energy, indicating that its solubility will be more in water as compared to that of sodium chloride. In the same way, the next factor that governs the solubility trends is hydration energy, which is the energy released when the ions of salt get hydrated in water. This indicates that when a salt is put into water, the ions of that salt attracts water molecules around it. Speaking of, they are getting hydrated. More the hydration, more will be the energy released, and hence more will be the hydration energy. This leads to the more dissolution of that salt. So clearly we can say more the value of hydration energy, more will be the solubility of salts. For example, the hydration energy of sodium chloride is around negative 783 kilojoules per mole, and that of potassium chloride is around negative 684 kilojoules per mole. On comparing, there is more energy release in case of sodium chloride as compared to potassium chloride. Therefore, sodium chloride is expected to be more water soluble than the potassium chloride as far as hydration energy factor is concerned. Now the point is, the same salt, that is sodium chloride, is less soluble in water as far as lattice energy is concerned, while it is more soluble in water as far as hydration energy is concerned. The actual nature of that salt in water is given by the combined effect of both the factors. So on combining the two, the energy changes involved in the case of sodium chloride is around 4 kilojoules per mole, while that of potassium chloride is around 33 kilojoules per mole. Clearly there is more endothermic dissolution in the case of potassium chloride than that of sodium chloride. So clearly we can say sodium chloride is more water soluble as compared to that of potassium chloride. Both these terms depend on the charge density of cations and anions. Charge density is nothing but charge by size ratio. Therefore, if the charge density of cations and anions is higher, the attraction between them will be more, and hence lattice energy will be more. This leads to poor dissolution of that salt in water. In the same way, if the charge density of cations and anions is higher, they'll attract more water molecules around them. In other words, they'll get more hydrated, thereby increases the hydration energy and allows more dissolution of that salt in water. For example, on moving down the group, charge density decreases because size of the ion increases. This leads to the poor attraction between the ions of crystal. In other words, lattice energy will decrease. This leads to the increase in solubility. In the same way, while moving down the group, charge density decreases since size increases. Therefore, the ions of that salt attract a less number of water molecules, and hence hydration energy will decrease. This leads to the decrease in the solubility of that salt. Thus, we got an important result, that is, if lattice energy decreases, solubility will increase, and if hydration energy decreases, solubility will also decrease. Now, which among the two factors dominates will depend on the nature of anion present in the salt. If the anions present are fluoride, oxide or hydroxides, these are the smaller anions, lattice energy will always dominate. However, if the salts are larger like bromide, iodide, sulfite, sulfate, carbonate, bicarbonate, nitrate, chlorate, phosphate, etc., then either the lattice energy or the hydration energy will be dominating, and this will depend on the number of cations and anions present in that salt. This indicates that all those salts containing fluorides, oxides or hydroxides as anions, the solubility of those salts will always increase down the group. This is because lattice energy is the dominating factor. However, in the case of salts containing larger anions as shown, one cannot directly tell you whether the trend is increasing or decreasing. This is because both the factors will be dominating, and it will depend on the number of cations and anions present. For this purpose, we have a simple trick, and that is we need to remember a mnemonic, that is clash. In this, C stands for cation number, L stands for lattice energy, A stands for anion number, S stands for same, and H stands for the hydration energy. Now, if the number of cations is more than the number of anions in a salt, then lattice energy will be the dominating factor. Once the lattice energy is the dominating factor, clearly solubility will increase down the group. However, if the number of anions are greater than the number of cations, or the number of anions are equal to that of number of cations, then it is the hydration energy which is the dominating factor. So, solubility will decrease down the group. This can be illustrated as we have alkali and alkaline metal fluorides, alkali and alkaline metal oxides, alkali and alkaline metal hydroxides. As I told you earlier, that there is the presence of fluoride, oxide and hydroxide in the salts. Clearly, lattice energy is the dominating factor always. Therefore, solubility has to increase down the group. Now, these are the iodides of alkali metals. As iodide is a larger anion, therefore we need to check the number of cations and anions present. As the number of cations is equal to the number of anions, because the salt is in 1:1 ratio, therefore hydration energy will be the dominating factor, and hence while moving down the group, solubility will decrease. Clearly, lithium iodide will be more soluble than that of sodium iodide, which will be more soluble than that of potassium iodide, and so on than that of cesium iodide. In the same way, while looking at the iodides of alkaline earth metals, the number of anions are greater than that of number of cation. Clearly, hydration energy is the dominating factor. Therefore, solubility will again decrease down the group. In the third case, as you see, these are the sulfates of alkali metals, and the number of cations are greater than that of number of anions, because the ratio is 2:1. Therefore, lattice energy will be the dominating factor, and which will lead to increase in solubility down the group. I hope you understand this. Now, I am asking you to give the trend in solubility of the nitrates, chlorates, oxalates, phosphates of group 1A and 2A metals. Once you solve it, please write the answers in the comments. Till then, take good care of yourselves. Thank you.